just like with mathematical operators, addition, subtraction, multiplication, etc., we can use arrays and scalars and matrices all combined together. Same thing with relational equality and logical operators. We can compare scalars and or arrays. When we compare two scalars, a scalar is produced. So a scalar produces a scalar. When we compare arrays, the default is element by element. In fact, there's no other way it's going to do it. It's going to do element by element. We can compare an array with a scalar. It's going to produce an array. We can compare an array with an array. It will also produce an array. Remember, it's element by element. So my arrays need to be the same size. One thing that MATLAB allows us to do, given this mentality, given this behavior, is something called logical indexing, where we can essentially use an array of logical values to extract values from a different array. So here's my original array. Here's a logical array. These need to be the same size. And what it's going to do is it's going to take all of the true values in here. It's going to take all of those locations inside of this array and extract those elements. So essentially it deletes all of the locations that are false. So this allows us to easily extract elements in an array. So I'm going to go over a very brief example of this just to demonstrate it. So let's say that we had a matrix full of random values. So I'm going to do from negative 100 to 100. So my range of values is going to be negative 100 to 100. And let's say I had 10 rows, 10 columns. And I want to extract all of the elements that are positive and all of the elements that are negative. So what I can do is I can figure out the locations of my positive elements by just saying a greater than 0. And we'll make 0 a positive number. So a greater than 0. My negative locations, a less than 0. Okay, so let's run this. We'll run this. So here's A. All of my negative locations, or my positive locations, are right here, where all the ones are. And all of my negative locations are here where all the ones are. So these two should be opposites of each other. Now what I can do is I can say that my numbers that are positive are where A has a positive location. And my negative numbers is where A has a negative location. So if I run this, here I've extracted all of my positive numbers, and here's my negative numbers. It does do them in columns. It's not going to be exactly a 10 by 10 because it can't delete or remove and extract elements in a guaranteed square way. But here I can see that these are all the negative numbers that were in my array. Here are all the positive numbers that were in my array. And if I go over to my workspace, I can see that array, or A was a 10 by 10, which means locus negative was a 10 by 10, locus positive was a 10 by 10. Numbers negative is 60 by 1. That means there were 60 negative numbers. And nums pos is 40. That means there were 40 positive numbers. So here it's called logical indexing, where I am going to extract elements using a logical array of the same size.